In this video, we're going to be going over how to get some angles inside of a circle that aren't quite in the center or inscribed. You'll notice in this problem, you'll see this angle here, x, and it's not inscribed because it's not touching the edge of the circle, nor is it in the center here. So what we want to do instead is take the average of these two numbers. And let me get into why that is real quickly without getting too formal about it. If you want to skip a little bit ahead to get to the examples, that's fine. But if you're curious to know why it is the average of these two numbers, you want to think about, let's call these angles some numbers. Maybe I'll say this is 110 degrees, and I'll call this 40. Okay. Now, if I were to make an inscribed angle from that 110 degree angle and just kind of extend that and make this meet the arc where that 110 degree arc is. So you see this 110 degree arc right here. Then I would have this angle be 1/2 of this 110 degree arc. So that would be 55 degrees. Okay. In similar fashion, I can do the same thing with this 40 degree arc from this side. So if I go to this side and I take that 40 degree arc and cut that in half, that's going to be 20. Well, now I have myself a triangle. So let's think about if I have a triangle that has 20 degrees, 55 degrees, and I can get that third angle in a triangle because I know all triangles, the sum of the angles is 180 degrees. So I can do 180 minus the sum of 22 and 55, 20 and 55. And 20 and 55 are going to add to 75. So 180 minus 75. And that's going to get you 105. So I know that this angle is 105. Well, what does that mean? Well, I can go into this triangle here. Let me erase this for a second. So I can go back into this triangle, knowing that's 105 degrees. I can plop that right there. Now, any two angles that form a straight line also add to 180. So I know that x is going to be 180 minus 55, 105. And that's going to give you 75 degrees. So x is going to be 75 degrees. And these two angles themselves, they're called vertical angles. They're actually the same degree measure. They're the ones that face these two arcs. So let's think about what that means. If I have 110 here and 40, and I add those together, that's going to be 150. So if I take 1/2 of 150, or 150 divided by 2, I'm going to get 75 degrees, which is exactly what I found using that long method by getting inscribed angles. So the shortcut really is just add those two arcs on the outside, divide them by 2, and you'll get the angle that is facing those two arcs if it's not on the center. Let's get into a couple examples. All right, example 1. We have a 150 degree arc, a 68 degree arc, and a 44 degree arc. This is the angle we want to find. That's in the center. It's in the circle, not in the center. The center is probably about right here. So what we want to do is we want to utilize that formula, 1/2 arc plus arc. But we want to figure out these two arcs because the angle is facing those two arcs. So we have to get this missing arc down here. And because all arcs in a circle add to 360, I can once again say 360 minus the sum of the three arcs that you see. So I have 68, 150, and 44. So let's add those together and subtract that from 360. Doing so gives me 98. So 98 degrees for the arc that's going to be on the bottom of that circle. And now I have the two arcs that x is facing. So what I can do for x is I can say 1/2 times 98 plus 150. Okay, carefully calculate that. Let's see what we get. Doing so, I got 124 degrees, which is the answer to this question. So 124 degrees represents x. It's halfway between 98 and 150. All right, we have a few other ones here. If you'd like to try to pause the video to try number 2 and 3, then you can unpause them and check. All right, so what we first have to do is we have to look where X is, and notice that that's an angle again, but it's facing these two arcs. We have one of the arcs, we have the 92, but we have to get this one over here. So if you notice there's a 56-degree angle, that's an inscribed angle. That's opening up toward that arc. This arc then is going to be twice the inscribed angle. So I can calculate that by doing 2 times 56. Remember in a previous video, I was able to find an inscribed angle by taking the arc and dividing by 2. So if I want to get the arc, I would multiply it by 2. 2 times 56 is going to be 112. So now I have the two arcs that this angle faces, and I'm ready to plug it into the formula. So that angle is going to be 1/2 the sum of 92 and 112. Okay, those two add to 204, and then I can divide by 2 to get that 1/2 of it. And angle X is going to be 102 degrees. All right, here's number 3. Again, if you haven't tried number 3, pause it and see if you can try it first. All right, so what I want to do on 3 is first, I'm trying to find an arc, not an angle. So I have to work a little bit backwards. And the angle that's facing these two arcs is not the 98-degree angle. In fact, I have to get that angle by subtracting this 98 from 180 since it forms a straight line with that 98-degree angle. So I'm going to first do 180 minus 98. 180 minus 100 is 80, so it should be 82 degrees. Next, that's a terrible drawing. Fix that real quick. 82 degrees. The next thing I want to do is set it up into the formula. Now I have the angle, that's this value over here. So I'm going to write 82 is equal to 1/2 parentheses x plus 97. So to solve that, I'm going to want to multiply the 1/2 or multiply by 2 to both sides to get rid of the 1/2. So I'll do 2 times 82 to cancel that out. 2 times 82 is going to be 164. So we'll write 164 equals x plus 97. And at that point, I can subtract 97 from 164 to get my final answer. And let's do that. So 164 minus 97 is 67 degrees. So angle X, rather arc X, is going to be 67 degrees off to the side. We'll write that over here. And remember, 82 is the average of 97 and 67. If you're not quite sure if your work is right, you can always go back and check. So if I do 97 plus 67 and take that number and divide by 2, that'll get me the 82 there, which is 180 minus 98. All right, I'm going to do the 3 that are below. They're a little bit trickier here, but go ahead and let's take a look at them. Let me clear this off first. If you would like to, once again, pause the video and just try them on your own and unpause it, and I'll work them out as we go. All right, so question number 4. In this case here, P is the center of a circle, which means 118 is considered the central angle. So I know that that arc is going to be 118 degrees based off that information. So I'm going to go ahead and put the 118 there. And I want to find angle X. That is the angle inside the circle, not in the center. So it's just going to be like the previous formula. You're going to do the average of the two arcs. We use the 118 and the 23. Add those together and divide by 2, and you'll have your answer. 118 plus 23 is going to be 141, I believe. Then we'll take that number and divide by 2 to get your angle X, and that's going to be 70.5 degrees. Question 5, we want to find arc X over here. It says P is in the center, which means this segment right here that's going through the center is going to be a diameter. Now, I'm gonna focus on first the angle and the arc that I have. Since the angle 38 is facing this arc and this arc, I'm gonna go ahead and get this arc. We'll call it Y. And so to get Y, I'm gonna set up the 38, the 23, and the Y in the formula. Remember, this is your angle, so that's gonna be 38 over here equals 1/2, and then I can do the sum of these two, so Y plus 23. So we did a previous problem like that before, where we wanted to multiply both sides by 2. And 2 times 38 is going to be 40 times 2 is 80, so 76. And that's going to be equal to Y plus 23. From there, we can subtract 23 from both sides. And you're going to get 53 for the value of Y. So what do I do with that 53? Well, you got to realize that this right here is half the circle. So that X and 53 are both going to combine to add to 180. So what we're going to do is we're going to do 180 minus 53 to get your answer. And so arc X will be 130, so 127 degrees. That'll be your final answer. All right, and finally, question number 6. Again, set it up and try it if you can, and you can unpause it if you need to. All right, so I have the angle facing the two arcs. I don't have to do any subtraction from 180. Notice I have both of these as x's. So this will look a little bit more algebraic, but let's get it started. We have our angle is equal to half. And then we add the two arcs, so 2x plus x. Now this isn't inherently hard to solve. You just want to combine the like terms. So first thing I want to do is get rid of the 1/2. So I'll multiply both sides by 2. That'll cancel those out. 2 times 87. 2 times 80 is 160. So 174. These will combine to 3x. And then we're going to take 174 and divide by 3 to get your answer. So 174 divided by 3 will get you 58. Now, x is 58. It doesn't ask you for the arcs, but you can get it if you wanted to. 58 degrees is definitely this one over here. And if you wanted to know this one, well, you could take it times by 2. So 2 times 58, that's going to be 116. And if you double check there, and if you add 116 and 58 and divide that by 2, you should end up with 87. So let's do that. And there you go. All right, that concludes this video on angles inside of a circle that aren't in the center or inscribed. The next video will be going about angles outside the circle. Thanks for watching.